everyone, my name is Boris Savic, this is Andrzej, and the other team members are Blaž, Sasha and Simon. They're sitting at the back. And we're going to present you the project named Smartshirt. Well, we all know that life is filled with stressful situations. We go to work, we're stressed, we go to school, we're stressed, we're presenting in front of our group, we're stressed. We are in a relationship, we're stressed. And stress can be your friend at the moment because it motivates you to do something with your life, to move on. But it can also be dangerous if it exceeds the healthy levels. Recent studies show that stress can be linked to several diseases. It's not causing those diseases, but it's not helpful if you're feeling stressed and you're prone to these diseases. Such diseases are obesity, Alzheimer's, diabetes, asthma, and many more, especially heart diseases. Some of us are prone to heart diseases. They might be genetic or something, but stress can make this process of getting worse even faster. We can't prevent stress entirely, but we can make sure we reduce it where it's possible. But in order to do so, we should first locate the sources of stress. You might all think that you all know when we're being stressed, but reality is that our body is feeling stressed even when we don't actually realize it. And that's why we would like to introduce a product named Smartshirt. It's a lightweight t-shirt equipped with sensors that are collecting the physiological data throughout the day and sending this data to your mobile client, which then later communicates with server. At the moment we are collecting electrocardiogram data, ECG, which will be presented in depth a little bit later by Andrzej. The other sensor we are using is EDA, electrodermal activity. This sensor monitors your skin activity, mostly the amount of moisture on your skin, which is released when you're feeling stressed. These sensors are collecting the data at the sample of 1000 Hz. This means that 1000 samples are being collected each second. And as you all can calculate pretty fast, that's quite a lot during the day. And that's why we are not storing this data on a mobile phone, but actually sending it to a server, which is more powerful, and it doesn't use your battery on your phone to analyze this data. The server then uses smart algorithms that we have developed to analyze this data and communicate back to a mobile client your average feeling throughout the day. So it notifies you when were you stressed the most, what should you be looking out for the next day, and so on.
Okay. So I'm going to talk a little bit about the technical side of the project. For our main hardware component, we use the Vitalino board that consists of several modular sensors, which can be also broken off and used individually. So for an example, we have the EMG that measures the electrical activity produced by your muscles, the EDA, electrodermal activity that senses your sympathetic nervous system reactions, and on the other side you have the ECG and ACC that measures your movement. So our app communicates with the board via Bluetooth. So the first feature we implemented is EDA detection that, as Boris also already said, detects your moisture and conductivity, skin conductivity. So whenever you're under stress, whenever you're frightened or something like that, your sympathetic nervous system reacts by, you start sweating, you probably know that. So. Okay, the second feature is heart rate detection. On the image here you can see QRS complex. So this is a building block. It represents one heartbeat. As you can see, it consists of several segments from P to T. All of them are really important when we are trying to detect different symptoms of heart diseases and episodes, for example, ischemic episodes. But as we are concentrating only on heart rate, this one is important, R, and we're trying to attenuate others. So the main issue here was noise in the data that's produced by the sensors. So whenever you move your body, whenever you start sweating, if you have body hair, there's lots of noise in the data. So this is a nice example. You can see that the signal wanders up and down. This is called the baseline wander. And this is actually just low frequency noise and can be easily filtered out. So we have a couple of filters. A few of them just attenuate and extract peaks, and a couple of them, I think, extract slopes. Yeah. Okay, so this is it. Oh, sorry. Yeah, I forgot. We tested this algorithm on 24-hour records of more than 100 patients. We got that data from the PhysioNet APM database, and the results were very promising. So we got sensitivity and positive predictivity levels of over 95%. So in more than 95%, our predictions of heart beats were correct. But we're not concentrating on if the heartbeat is abnormal or normal, just counting the beats. Okay, here we have a couple of screenshots of our app. The first view, the real-time view, you can see nothing because the line is dark blue. Okay, yeah. So here we're displaying a live feed from the sensor, the ECG sensor, so you should see an ECG line here. The second view, the data view, shows the results from the server. The results are grouped by location, so I mean you need some context to know to read out the data. This makes it easier for the user to see how he felt during traveling or at home. And the last view, the analysis, simplifies the data more, again to simplify the data.
So we already presented us how we do it, and I already told why we do it. Main benefit is so that we discover the stress sources and eliminate them. The technology can do that for us, but it can help us find some answers that we don't know where to look for. And after the app on the previous page, for example, shows us that we were traveling and feeling stressed, for example. This view at the moment is not perfect, it doesn't tell you much for now, but we could integrate more emoticons in order to present your current state during traveling, and you could later tell, okay, I was actually a little bit nervous, I should try to calm myself down. And that's it about the benefits actually, so we can't do everything for you, but you'll have to do the rest. Possible applications, we're actually just scratching the surface here. I mean, the same product can be used also as a sports accessory when you're running, climbing, etc., to monitor heart rate, so on, or even as a monitoring solution for elderly people at home, so that the nurse can be in her room and monitor the patient's activity and their stress levels and know when a certain patient feels stressed and they should go check on him. And as Angel already touched the item of ischemia, it's one of the most common heart diseases in the modern world, and it's really difficult to detect it early enough. It's possible to do so only by recording 24-hour ECG records during the normal day activities. And this amount of data must be processed automatically, because 1,000 samples per second, 24 hours produces a lot of data for human to go through. And with algorithms, we haven't actually developed them, but they exist and they can be implemented using similar techniques as he already mentioned. But we're not looking at R peaks, but Q and ST segments that were displayed on the image before. So yeah, but not to get lost in the possibilities, We still have a lot to do. Our current implementation is just a bunch of wires, a Pitilino board, and a shirt over the wires to cover us. We should integrate this within an actual shirt. It's really lightweight because the battery is smaller than on a phone and lasts over a day. And of course, even though our algorithms at the moment work, there's always room for improvement, and we can learn from the data we collect what is significant for stress factors in other people. And of course, graphical improvements of the app and web application. That would be all. I would like to thank you for your attention. Demo because it wasn't viewable on the
I think
image.
all correct.
So we'll see how stressed is he actually, his heart rate at the moment. The
Change the color so comfort.
How do you?
Where's the camera?
Something.
So this is Sasha's heart rate at the moment.
He's a little bit nervous.
So this is real-time data, but we can't now wait for 10-15 minutes so that the data gets sent to a server and then processed back. It takes at least 10 minutes to find a state of the human at the moment. So, yeah.